Hello, students. I'm Mansi Agarwal, Assistant Professor, ABES Engineering College, Ghaziabad. Today, we will be discussing our next topic of data structures, that is collision resolution techniques in hashing. In the previous video, we have seen what is hashing and how the collision occurs. And in this video, we are going to discuss the various techniques that are used to resolve the collisions. Now, what is collision? As we have seen in the previous video also, when hash function maps two different keys to same hash value, then it is called collision. So suppose let us try to understand how the collision occurs with the help of an example. Suppose we have two input keys, like we can have 23 and 8. And we want to map these keys on a hash table having 5 slots, right? So the value of M here is 5. And the slots will have index 0 to 4, right? So if we map these two keys with the help of division method and the table size is 5, then for 23, we will divide it by 5 and we are going to find out the remainder that will come out to be 3. So for 23, this will be mapped at index 3, right? So the value of HK, that is H23, will come out to be 3. And again, if we take the next key, which is 8, again, if we will divide it by the table size 5, we will get a remainder 3. So this will again be mapped on the same index 3. This is where the collision occurs. We are trying to store the same keys at the different keys at the same index. In order to resolve this collision, we have various techniques which are called the collision resolution techniques. The collision resolution technique refers to methods used in computer science, particularly in hashing, to handle situations where two or more keys are mapped to the same location or index in a hash table, as we have just seen. This event is called collision. Now, in order to resolve the collision, there are two ways, two techniques. One is called separate chaining. One of the technique is called separate chaining, which is also called open hashing. Because this is called open hashing because some extra space is used in order to resolve the collision. And the second way is open addressing, which is called closed hashing, as no extra space will be used to resolve the collision. Under open addressing, we have various methods like linear probing, quadratic probing, and double hashing. So we are going to look into all these methods one by one. Open hashing. Open hashing, also known as separate chaining, is a collision resolution technique used in hashing. In open hashing, each slot in the hash table points to a collection. Typically, it is a linked list of all the elements that are hashed to the same index, right? Let us now try to understand how the open hashing works with the help of one example. Suppose we can take a few keys, like we can take 52, 29, 30, and 72. And suppose the hash table is of size 5. That means there are 5 slots starting with 0, 1, 2, 3, and 4, right? And we are mapping these keys again with the help of division function. So in order to do this, h of 52 will be equals to 52 mod 5, which will give you 2. So we can say that 52 will be mapped at index 2. So in case of open hashing, what we are going to do is we are going to create a single linked list here. And every node of this linked list will store the value of the key. So here 52 will be stored here in the node, and the address of the node will be stored in the at the index 2. Right? Again, we have to map value 29, and as you can see that 29 will be placed at index 4. So here again we will make a linked list, and the node will have the value 29. In order to map value 30, we can here see that this value 30 will be mapped at index 0. So here we will create another linked list at index 0, and this will store the value 30. But for the last value, which is 72, now this is the point where we are getting a collision, right? So 72 mod 5 will again produce index number 2. In order to resolve this collision, we are going to add the 72 to the linked list, which is there at index 2, right? So here 72 will be added as a new node in the linked list, which is stored at index 2. This is how the open hashing works. The advantages of open hashing includes that the hash table has unlimited size, as you have just seen that whenever a new key value comes, we have to simply create a new node and we can add the value, the key value to that node. So there is no limit to the size of the hash table. Simple to insert the node in case of collision. We have to only create a new node and we have to add it to the linked list of the same index. Then the disadvantages of open hashing includes chaining by linked list cost extra space. As you can see that in order to resolve the collision, we have taken linked list at every index. So this creating this linked list is definitely taking extra space. And searching for any element in the linked list may reach to ON. Suppose all the keys are mapped on the same index. In that case, the linked lists that will be formed will be of size n. And in order to search any key value in that linked list, the time complexity may reach till ON. So this is the time complexity. The average case time complexity is O1 plus n by m. Best case is O1 and worst case is ON. While that of the space complexity is OM plus n, where m is the number of slots in the hash table and n is the total number of keys. Coming on to the next collision resolution technique, this is closed hashing. Closed hashing is also known as open addressing, and it is a collision resolution technique used in hashing where all the keys are stored directly within the hash table itself without the use of external data structures like linked lists. When a collision occurs, alternative locations within the table are probed to find an empty slot for the new key. Now, in open addressing, as you know that it has been discussed in the video that there are various techniques for open addressing. The first technique for open addressing is linear probing. Linear probing is a collision resolution technique used for open addressing where upon encountering a collision, the algorithm searches for the next available slot in the hash table by incrementing the index sequentially in a linear manner. So here, if hk, that is the hash function, if it is represented by k mod m, if we are using the division method, then hash function for the linear probing, which is represented by h dash ki, will be represented by hk plus I mod m, where I is the number of probes that you are doing in order to avoid the collision, in order to resolve the collision. So this can also be understood with the help of an example. Let us take some key values. Suppose the key values are 43, 135, 72, 23, 99, 19, and 82. And suppose the table size in which we are going to map these keys is 10. Suppose the table size is 10. So let me just create the slots here. 6, 7, 8, and 9. Now, suppose we are mapping these key values with the help of division method. So in this case, HK will be represented by K mod M, right? Suppose now we have to map the first key, which is 43. This will be mapped by dividing 43 by the table size, which is equals to 10. And here we will get the value 3. So 43 will be stored at index 3. Then in order to map 135, it can be seen that 135 will be mapped at index 5. This is 135 will be mapped here. And similarly, for 72, we can see that it will be mapped at index 2. So 72 will be mapped at index 2. Then 23. Now, as you can see that for 23, again, the index that we are getting, the hash value that we are getting after applying the hash function is 3. And this is where we have got the collision. Now, in order to resolve this collision, we are going to find out the hash value again with the help of hash function h dash k, that is 23, comma I. So the value of I will start from 1 because for the value of I 0, we have already found out the value which is 3. Now, in order to find out for the first probe, the value of I that will be equals to 1, this will be represented by hk plus I mod 10. So the value of hk here is 3, as we have already computed this in the previous step, plus the value of probe, that is the value of I is 1 mod 10. Now, as you can see that this will provide us a value 4, and we can see that the index 4 here is vacant. It is empty. So we can store 23 here in the other index 4. Suppose if this index 4 was also occupied by some value, then we have to probe it further. We have to take the value of I as 2 or the value of I as 3 till the time we must get any vacant slot in the hash table. Right? Now let us again check the hash value of the next key, which is 99. Now, as you can see that the hash value for 99 will come out to be 9. And block 9 here is empty. So we can simply place 99 here. But again, when we are going to find out the hash value for 19, it will again become 9. And again, this is a situation where the collision is happening. And in order to resolve it, again, we are going to use the linear probing function, which is h dash. And here h dash 19, comma 1 will be represented by hk plus 1 mod 10. So that means it is equals to 9 plus 1 mod 10. 9 plus 1 mod 10. And this is going to give us 0. So this 19 will be mapped at index 0. Similarly, for 82, you can see that for 82, again, there is a collision. For 82, we will get a value, hash value of 2. And so again, we have to probe it. We have to probe it. And for this, again, we are going to use the linear probing function, that is 82, comma, the value of probe will be 1, that is I, right? So this will again be represented by 82, comma I, that will be represented by HK, which is 2, plus 1, plus 1 mod 10. And in this probe, we will get a value 3. But as you can see that index 3 is also occupied by 43. We cannot place 82 here. So now we have to keep on probing it. We have to keep on probing it and we have to increase the value of I. So the value of I now will become 2, right? And it will become 2 plus 2 mod 10. 2 plus 2 mod 10, which will give us 4. Again, you can see that index 4 is also occupied. So in this case, again, we have to increment the value of I and it will become 3. And as the value of I will become 3, the h dash function will give us 2 plus 3 mod 10. And the value here will become 5, right? Again, the index 5 is preoccupied. So we are going to probe it with the value of I as 4. And this time it will become 2 plus 4 mod 10. This is now going to give us the index 6. And as you can see that index 6 in the table is empty, then we are going to store 86 here at the 6th index in the hash table. The advantages of linear probing includes, as you can see, that no extra space have been taken in order to resolve the collision. So this is one of the main advantage of linear probing. And the disadvantages here include primary clustering. Now let us understand what is primary clustering. As you can see that we are linearly probing. Like if here we see for 82, for 82 index 2 was not empty. Then we went to index 3, it was not empty. Then we went to index 4, it was not empty, and so on. So as you can see that the values, the indexes that we are using in order to store any key value which is giving us any collision, the index that we will get, it will be near to the indexes which are already filled, right? Like if we get any collision at 2, 3, 4, 5, or 6, then for all these indexes we will have 7th index in order to fill the key that is giving us a collision. So this is called primary clustering, where all the key values are being stored in clusters, right? Rather having a uniform distribution in the hash table. The second disadvantage of linear probing is the deletion process of linear probing is difficult. And the third disadvantage is the worst case time complexity for linear probing may reach till ON. So as you can see that the time complexity in average case is represented by O, 1 upon 1 minus n upon m. The best case is O1 and the worst case is ON. And the space complexity is given by OM plus n, where m is the number of slots in the hash table and n is the total number of keys. Coming on to the next technique of collision resolution, this is called quadratic probing. Quadratic probing is a collision resolution technique used in open hashing or closed hashing, open addressing or closed hashing, where upon encountering a collision, the algorithm probes for the next available slot using a quadratic function rather than a linear function, right? So with this quadratic function, you can here see that earlier in the linear probing, we were just looking at the next available slots, which was causing a primary clustering. But here, as we are using the quadratic function, it is not necessary that the next available slot will be used for avoiding the collision, for resolving the collision. Rather, there can be any available slot in the hash table. So in order to use the quadratic probing, suppose if the hash function taken is k mod m, then hash function for quadratic probing, that is h dash ki, will be represented by hk plus I square. I square represents the quadratic function here, and then we are going to mod it with the table size m. Right. So in order to understand how the quadratic probing works, let us just take an example. So in order to understand the quadratic probing, let me just take a few keys and we are going to see how the collision will be resolved. Suppose the keys that we are taking are 42, 16, 91, 33, 18, 27, 36, and 62. Right? And suppose the table size is same, and the table size here is of 10 slots. So let me just create a hash table here. Right? So this is the hash table. Now let us first map 42. So in order to map 42, we will divide this 42 by 10 and we will find out the remainder that comes out to be 2. So 42 will be mapped at index 2. And similarly, for 16, we will get a value 6. So this will be mapped here. 16 will be mapped here at 6th index. Then for 91, you can see that we will get an index 1. So 91 can be mapped here. And then 33 will be mapped at index 3. So let us just map 33 here. And 18 will be mapped at 8. So 18 is here. And 27 will be mapped at 7. So let us store 27 here at index 7. And now for 36, as you can see that if we divide 36 by 10 and see the remainder, that will come out to be 6, right? And we can see that index 6 is already occupied by 16. So here we have got a collision. And in order to resolve this collision, now we are going to do quadratic probing. So for quadratic probing, we will make h dash function with a key value 36 and the value of I is 1, right? And this will be calculated by hk plus I square, which will give us 1. And then again, we are going to mod this value by 10. So here we are getting 7. But at 7, you can see that again there is a collision as the index 7 here is not empty. So again, we are going to probe it for the second time and the value of I will become 2. So we are going to find out h dash 36 comma 2 and it will be calculated by hk plus I square mod 10. So this will become hk will become 6 and I square will take a value 4 and then we have to mod it by 10. So here we will get 0. And as you can see that index 0 is empty. So we can store 36 here and it will become, will be stored at 0th index. Now again, if we want to store 62, we have to calculate the hash value for 62. The hash value of 62 will become 2. And again, we are going to get a collision. As you can see that, the index number 2 is not empty. So again, we are going to calculate the quadratic probing. And here the function h dash 62 comma 1. 62 comma 1. And you know that this will give us 2 plus 1 square, that is 1 mod 10, which is equals to 3. Right. And again, you can see that this 3 is, index number 3 is not empty. So again, we are going to probe it further. We are going to probe it 62, comma 2, right? So if we probe it for 62, comma 2, we will get a value 2 plus 2 square, that is 4 mod 10. And this time again, we are getting a value 6. We are getting a value 6, right? So again, at index 6, there is a collision. So we are going to further probe it for 3. And here we will get 2 plus 9 mod 10. 2 plus 9 mod 10. And for this, we are going to get a value 1. And you can see that index 1 is also occupied. Let us try to probe it for one more time. Okay. So we can just probe it with 4. So here we will get 2 plus 16 mod 10. And the value that we have got is 8. And you can see that again, index 8 is occupied. So this is a drawback of quadratic probing, that there is no guarantee that we will be able to resolve the collision, as for every time that we are calculating the hash dash value, we are calculating the hash value with the help of quadratic probing, it may lead to an index which is already occupied, right? So this is one of the disadvantage of quadratic probing. So the advantages of quadratic probing includes no extra space is required to resolve the collision and no primary clustering is there. But the disadvantages includes that there is no guarantee of getting the free hash table slot. And in worst case, the time complexity may reach to O(n). So the time complexity is, in the average case, it is O1 plus n upon m. In the best case, it is O1. And in the worst case, it is On. While the space complexity here is Om. Coming to the next probing technique, this is double probing, also known as double hashing, is a collision resolution technique used in open addressing or closed hashing, where a second hash function is used to determine the step size for probing when any collision occurs. This ensures that the probing sequence for each key is unique, significantly reducing the clustering issues. So here, if one of the function is represented by h1k, which is, suppose if it is division method, it is k mod m, and h2 will be represented by p minus k mod p. And in order to avoid collision, h dash k comma I, where I is the probe, is the number of probe that we are doing, is represented by h1k plus I into the second function that we are using, that is h2, and then taking mod of them all together. Right. So let us just try to understand this with the help of an example. Let us take a few keys. Suppose the keys that we are taking are 20, 34, 45, 70, and 56. And suppose the table size is 11, right? So the number of slots in the table are 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the number of slots will range from 0 to 10, as the value of m is 11, right? So let us first hash the first key value, which is 20. So h20 will be stored at the index 20 mod 11. and this is equals to 9. So 20 will be stored at index 9. Now suppose we want to hash now 34. For 34 again we are going to mod it by 11. And 34 mod 11 will give us value 1. So 34 will be mapped to index 1. Right. Now, suppose we want to map 45. Now, in order to map 45, you can see that 45 mod 11 will again give us index 1, and this is where the collision will occur. So, in order to resolve this collision, we are going to use h dash k function, k comma I, and the value of I will be represented by 1. So this will be 45 comma 1, and this will be represented by hk, which is 1 plus 1 into h2. So all these functions were h1 function, but now we have to also calculate h2 function for 45. So suppose for calculating h2 function, the value of p is taken as 8. So this will be represented by 8 minus 45 mod 8. As by definition, the value of h2k was given by p minus k mod p. So this will give us a value of 8 minus 45 mod 8 will give us 5. So this becomes 3, right? So here in the h dash function, we are going to use h1k plus I into the value of I is 1 into h2k, and the value of h2k is 3. And then we are going to mod this value overall by m. So here we will get 4 mod 11, and that will come out to be 4. So we can see that we can map this 45 here at index 4. 45 can be mapped here at index 4. So this is the way how the double hashing or double probing will be done. The complexity of double hashing in average case is O1 plus n upon m. In the best case, it is O1, and in the worst case, it is ON. The space complexity is OM. The references taken in order to create this video includes Tenenbaum, Langsam, and Augustine's data structures using C, Horowitz and Sahani's fundamentals of data structures, data structure Shom series, and Thareja's data structures using C. Thank you.